Alright guys, welcome to my channel. In this video, we are going to master BFS using a very important problem called number of provinces. And trust me, by the end of this video, you wouldn't just solve this problem, you will actually understand how BFS internally work. So without wasting time, let's get started with the very brand new problem, that is number of provinces. So let's get started with this brand new topic. So let's start with the problem. We are given n cross n matrix where is connected of ij is equal to 1. If matrix of ij is equal to 1, then it means city of I is directly connected to the city of j, otherwise no any direct connection. A province is a group of cities that are directly or indirectly connected. Your task is to find the total number of provinces. So here what the problem statement is saying, that we have n cross n matrix, like as shown here. We have n cross n matrix, and if matrix of I and j equal to 1, then it means I is directly connected to j. Otherwise, if it is equal to 0, then it means there is no any direct connection between I and j. So our task is to find the total number of provinces. That means our task is to find the total number of connected component. So coming to our intuition, like what our thought actually for this problem. Don't think this matrix as a matrix, okay? Think it is as a graph. Like, wait, let me erase all this thing, and after that I will explain why you need to think it about like a graph. Okay, so let me so that means if there is a connection between 0 and 1, then the value of 0 matrix ij is equal to 1. Okay, I hope you got it. That means if there is any connection between I and j, then its value will be 1. That's all. So here what this line is saying, this line is simply saying that a province is a simply group of nodes that are directly or indirectly connected. Okay, so coming to our idea, what we can think about this problem, how we can solve this problem. So we have two traversal technique, we have two graph traversal technique. One is DFS and another is BFS. Okay, so in the previous video we have seen like how to use DFS in a real-time problem. So in this video we are going to see how we can use BFS in a real-time problem with the help of this problem. Okay, so let's get started with the BFS. If I start from any node, suppose this node will be this, my any node will be 0. Okay, if I will start from this node 0, then what will I do? I will check whether firstly I will take a visited array and check whether a visited of 0 is 1 or 0. Wait, let me show you. I will check visited of 0 equal to 0. That means this particular node is not visited, and I need to call BFS for this particular node. That means if it will satisfy this condition, then what I will do, I will simply call BFS for 0. Okay, that's our inner thought for this problem. Why BFS? That means I can choose DFS, there's many way. I can choose BFS, I can also use DSU. I will tell you later what DSU is. Okay, so one BFS traversal will give you one component, one connected component, and one component will be one province. Okay, so what will be our approach for this particular problem? like how we can solve this particular problem. What's our thought process for solving this particular problem? So firstly, what we need to do, we need to create a visited array. Okay, we need to create a visited array, and I will loop through all the nodes. If node is not visited, then I will call BFS for that particular node, and if BFS finishes, that means after BFS finishes, I will increment a count. That means we need to take a variable count. So let's take a variable count. I will initialize it through 0. Okay, so we know how to that means we know the algorithm of BFS, how to use BFS. That means we need to create a queue, we need to take a visited array, we need to iterate over queue while queue is not empty. Then we need to put out the front element, we will pop out, and after that we will check the adjacent of that particular element whether it's visited or not. If it's not visited, then we will push it inside queue, and the whole loop goes again and again until queue is not empty. Okay, so that's our intuition. Let's write the pseudo code for this. That means what we will do, like in the main function, what we will do, we will call for I is equal to 0 till n minus 1, and what we will do, we will check if phase of I equal to 0, then what we will do, we will simply call BFS of I and will increase the count by 1. Okay, that's our intuition for this particular problem. That's our approach for this particular problem. Okay, so this is what we need to write in the main function. We don't need to do anything extra rather than this. So coming to dry run, how we can solve this particular problem with the help of this pseudo code. So let's get started with the dry run. So suppose initially we have our we have a visited array that will initially it started from the 0. That means we initialize it with 0. So what we need to do, initially we will put all the 0 inside this. That means 1 0 2 0 3 0 and so. Okay, what will be the size will be n. Okay, so let me separate it so that it looks very clear. Okay, so now coming to start from the 0, we will start from here. What is this element? This element is 1. Okay, this element is 1. We don't need to think about this particular element whether it's 1 or 0. We don't need to think about it. I will tell you later what's the role of this one. Okay, I will tell you later in this problem. So coming to this index 0 comma 0, coming to this, what I will check for this particular node, that means for particular ith element that visited of 0. This is visited of 0. Is it 0? Yes, it is. So what we need to do, I will call BFS of I. That means I will call BFS of 0. Let's call BFS of 0. BFS of 0. So okay, in BFS of 0, what we will do, we will initially we have some visited array, we have queue, so that's the thing. Okay, so initially what we will do, we will mark this 0 equal to 1 as visited. That means it will become visited now. Okay, now I will push it inside a queue. I have a queue and I will push this particular node inside queue. That's done. And now what I will check, is the queue empty? That means wait, let me check a queue. Let me take a queue. so that everything become more clear. Okay, I will push 0 inside this, so that like I will push 0 inside this queue. Okay, so let me check. While queue not empty, what I will do, I will simply, let's take a current element, that is our front element of the queue. Okay, I will pop it. Okay, and I will check the adjacent. That means what I will do, I will check the adjacent of that particular current element, whether it's visited or not. If it's not visited, I will push it inside queue and I will repeat this process. That means I will iterate over, let me iterate over, for int j is equal to 0 till n minus 1. What I will do, I will check whether visited, whether I will check. Now the role of this 1 is come. We need to check whether if mat of current and j equal to 1. Let me okay, equal to 1, and it should be not visited. I hope it's clear. So what I will do, I will simply mark it as visited and I will post it inside queue. Wait, I will explain everything. Wait. Okay. What I am doing, I am calling BFS of 0. Wait. Okay. I am calling BFS of 0, and what I am doing, I am marking it as visited. So let me change it. Inside visited array, now this, wait, it's like, let me take a visited array, 1 0 and 0. Okay, I will mark it as visited, and now I will remove, that means I will push it inside queue. This 0 will be inside queue. Okay, now I will check whether queue is empty. No, queue is not empty. 0 is inside this queue. So what I will do, I will find the current. What is the current node? That is 0. 0 is the current node in this queue. So I will pop it out. So let me pop it out. Now our queue is empty. So let me write here. I will pop 0 as at out. Okay, now our queue is empty. Now we can scan its row to find the neighbor. So let me scan the row. This is the row. Okay, 1 1 0. J is equal to 1. Yeah, it's connected. So node 1 is the adjacent and not visited. So what we will do, that means I will start from this. Okay, I will start from this and I will check if matrix of 0 and 0 is 1. Yes, 0 and 0, because current element is 0 and j is 0. So I will check it's 1. Yes, it's 1. And is it visited? No. Is it not it is not visited. So what we need to do, I will mark it as visited and push it inside queue. Okay, I will push it inside queue. So let me push it inside queue. So okay, that's done. That's cool. And I will increase this count. So okay, I will increase this count because I have called BFS of 0 and BFS of 0 is complete. So we need to increase this count. Now coming to I is equal to 1. And hope that means I will pop it out. When I will pop it out, I will check its neighbor. Its neighbor is 0. So we don't need to call because we here it got failed because matrix of current 1 comma 0. I will mark it as visited. Okay, that's correct. That's totally correct. Okay, now for this you will check it's 0. So we don't need to do anything for this particular element. So we opt out from here. So now we will pop it. So let me pop it out. Okay, I will pop, and our queue is now empty. BFS is complete. We have visited node 0 and 1. 0 and 1 is a visited node. So we need to increase this count. I have increased this count. Now coming to step 2, that is we will check for I is equal to 1. We need to check, and I forget to mark it as visited. So let me mark it as visited. Okay, so now let me came here. I will check for I is equal to 1 whether visited of 1 is equal to 0. No, there isn't any kind of 0 at visited of 1. So what we need to do, we don't need to do anything. We don't need to call BFS of 1 because it's already visited. So we don't need to do anything. We will move forward. Now coming to BFS of 2. So I is equal to 2. If visited of I is equal to 0, visit of 2 is equal to 0. Yes, visited of 2 is 0. So what we need to do, we need to call BFS of 0. What we will do, we will mark it as visited. I will push it inside queue. I will pop, that means I will find the current element and pop it out. So the current element will be 2 and I will pop it. That means I will push, let me push it inside queue. Okay, and I will pop it out. Okay, I will pop it out and I will check its adjacent. Its adjacent will be like 001. That means it hasn't any kind of neighbor. You can see like for this is 0. So we don't need to do anything for this. And rather than this, there isn't any kind of neighbor that is 1. So we don't need to do anything. We need to mark it as visited and increase the count. Here BFS is here our BFS is complete, and we need to increase this count. Okay, that's correct. So the condition satisfy that I is we iterate from 0 to 2. That means n is equal to 3 here, and we iterate from 0 to 2 and everything is completed. So we need to return this count. That means the total number of provinces inside this matrix is 2. Okay, I hope you got this dry run. If you do something by yourself, then you will easily get it out. So take another matrix and try to dry run with yourself so that you can get it very easily. Okay, now let me come to my VS Code and write the code for this particular, okay. So yes, okay, we need to take a count variable is equal to 0, we need to take a vector for a visited array. With us of the size okay. Now coming to iteration, for int I is equal to 0, I is less than n, I plus plus, I will check if visit of I is equal to 0, then what I will do, I will simply call BFS for the particular function, a particular element I will pass grid and visited as a parameter inside this. Okay, and what I will do, I will simply increase the count. So let me print the count here, and after I will write the main function, that is BFS. Okay, coming to this, I will make it void. I will pass node, and I will like create a vector of vector, that is grid, and okay, let vector ampersand grid, and I will also create a vector of int of this. Okay, so what I need to do, I will mark this node as visited, that's true. I will take a queue, and what I will do, I will push this node inside queue, and I will check while not queue dot empty. What I will do, I will find the current element with the help of queue dot front, and I will also pop it out, and I will find the adjacent if visited of j. Let me wait. I will check whether grid of current and j equal to 1 and visit of j equal to 0, and what I will do, I will simply mark it as visited and push it inside queue. So let me run it, and let's see whether it's working fine or not. Okay, okay, g++ yt.cpp, okay, a.exe. So take input as 3, 110 110 0 0 and 1. So we got the number of provinces, so that means our code is totally correct. So I hope you got the solution, and if you enjoyed this video, please like, subscribe and share this channel. I hope you got this whole concept. So that's done. So we will meet in the next video. Till then, bye bye.